Hello friends, uh, welcome back to all of you on your channel, that is JE Physics Maniac. So in today's lecture basically we are going to see few standard applications of the concept that we have learned in electric field intensity, right from electric field produced by point charges up to electric field by continuous bodies. And specifically in our lecture, in our previous lecture, we have completed up to surface charge distribution. So I will limit the applications up to the surface charge distribution only. So here in this case, you can see that there is a line charge distribution which is given. This is plus lambda. It is an infinite rod. This is also plus lambda, infinite rod, and there is a semicircular portion here at the bottom which is also having plus lambda. So because of this entire distribution, they are asking what is electric field at point C, that we have to calculate. So now when we are going to see such kind of questions, the first thing we need to know is that the application will be of principle of superposition, right? All right, so we'll apply principle of superposition. So how will we apply? We will consider this is to be element 1, the left one. This is let us say element 3, and this is element 2. So as you can see, the point C, this is the center of the semicircle, is right here. So the position point C for element 1 and 3 will be a position for semi-infinite wire. If you remember the cases, so here I will see that element 1 and 3 will behave as uniformly charged semi-infinite where. Okay, right. So we know what is the situation or what are the fields for semi-infinite wire. So now here I can now write that for this element 1, one field will be in this direction, in the right hand direction. This I am writing, this field here I am writing as E1x, and in the downward direction it will be E1y. Similarly, if you think about 3, so for the third one, in the leftward direction will be, I will write E3x, and in the downward direction will be E3y. And due to this semicircular portion, the electric field will be in upward direction, that is along y. We have also calculated that. So let us say this is E2y, and we have to know that E2x is basically equal to 0. There will be no x component for this semicircular portion. So now one by one, if I write E1x, that is equal to E2x, which is equal to k lambda by r, if I consider this radius to be r. Similarly, E1y, sorry, this is E3x. E1y is equal to E3y, that is also equal to k lambda by r, and E2y is basically equal to 2k lambda by r. All these are previous calculated values. You have to remember those values. So from these values, if you check, summation of Ex is becoming 0, as this and this will cancel each other. And in the y direction downward, it will be E1y plus E3y. So k lambda by r plus k lambda by r, it will become 2k lambda by r. E2y, as per our previous calculation, is also 2k lambda by r. So summation of Ey is also becoming 0. So the net field at C, the answer that we are getting is basically 0. This is the final answer. So whenever you are getting such kind of situations where you have to find out electric field for charge distribution, my suggestion will be you distribute into different segment, then try to find an analogy with the previous case that we have done and substitute the formula accordingly, right? Okay. Next, let us move on. So there is also an infinite where you can see extended up to infinity, plus infinity and minus infinity. And there is a charge particle which is released at which point the charge particle is released at this particular point when it is at a distance of 20 centimeter from it. So it is already mentioned that the charge particle is at 20 centimeter from the wire, and at that point of time it is also given as per the diagram when the charge particle was at 20 centimeter from the wire, it was feeling an electrostatic force of 100 newton. So that is an information, extra information being provided. Well, we'll use that data. Subsequently, what they are asking in the question, they are asking that if the charge particle is released at that particular position, find its speed when it is at a distance of 40 centimeter from the wire. Since it is a positive charge, and as we already know that due to this infinite line charge, the electric field line or the electric field will be in this direction. It will be in horizontal direction. So this is the direction of electric field. And since it is a positive charge, so it being a positive charge, it will feel a force also in the rightward direction. So I can write F vector is equal to Q into E vector. All right. So it is feeling a force also in the rightward direction. So when it is released, the charge particle will try to move in the rightward direction, obviously. So it will move away from the wire. Correct. So they are asking what is the speed at a distance of 40 centimeter from the wire. No problem. So I'll just do step by step. At a distance r from the wire, what is the electrostatic field? We know that this is nothing but equal to 2k lambda by r. So what is the force it is acting there? That is equal to q into E, that is q into 2k lambda by r. Now one information is already provided. I told that electrostatic force is 100 Newton when it is at 20 centimeter away. Now essentially all the calculations we do in SI system. So this centimeter we have to convert it in meter. So I will write that 100 is equal to 2kq into lambda divided by 20 centimeter. 20 centimeter means 0.2 meter. So if I multiply, it will become 20. 20 is equal to 2kq lambda. So from there, kq lambda value we are getting it to be 10. Now we will use that result later in the due course of the question. Now it is released, so it is moving in the rightward direction. So r value is changing, r value is increasing, so force value is obviously decreasing. Correct. And here we have written F is equal to Q into 2k lambda by r. Achha, force is equal to, we can write mass into acceleration, that is equal to 2kq lambda by r. Right. Now you see, we can write acceleration as 2kq lambda by m into r. Right. So we know what we know. We know that when I have to express acceleration as a function of distance, then at that point of time it is written as v dv dr. Right. It's very simple. I hope all of you remember. It's very silly. Acceleration equal to dv dt. So through chain rule we can write this is equal to dv dr into dr dt. Now this dr dt is basically v, so it turns out to be v dv dr. So a equal to v dv dr. So this result I am going to use because previously I got the value of a, that is equal to 2kq lambda divided by m into r. If I am not wrong, this is the value. This is equal to v dv dr. All right. Now I will just separate the variable. So v dv is equal to 2kq lambda by m. This is a constant term, so I kept it out of this, and then dr by r. Now I will integrate this. So if I integrate this, initially it was at rest when it is being released, and then it is at speed v at a distance of 40 centimeter. R initially from the where as 20 centimeter means 0.2 meter. Finally, they are saying 40 centimeter means 0.4 meter. So it's a standard function of integration. All of you know that it comes to be log R. So I'll simply write v square by 2 is equal to 2 kq lambda by m log of R, and the lower limit is 0.2, upper limit is 0.4. So I'm going to leave it here. As you all know, I don't do the calculation up to the end because it is a practice that you have to do so that you people are engaged in this, and it is very, very important that you are engaged with the calculations. Physics demands engagement. Okay, all right. Chalo, let us go for the next case. So in the next case, you see there is a ring, and which is also is uniformly charged with linear charge density lambda, and there is a particle of mass m and charge minus q is constrained to move along the x-axis or along the axis of the ring. Find the nature of oscillation for small oscillation about its mean position. Now, first of all, the first thing I will write is that the electric field due to a ring is basically kqx by r square plus x square to the power 3 by 2 if I take its radius to be capital R. All right. Now they are mentioning about this mean position. So for mean position, force acting on the charge should be 0. So if the force acting on the charge is 0, it means electric field has to be 0. So it is at x equal to 0. Although at x tends to plus minus infinity, field will be 0, but I am not taking those points at the reference point. I am taking the reference point to be at the center, that is at x equal to 0. Now there the particle is given a small disturbance, means suppose it is being disturbed or perturbed. In mathematical term, these are called perturbation. In higher studies you will see, especially those who will do post-graduation in mathematics, you have to study the perturbation theory out there. So anyway, this small disturbance is called perturbation. So it is perturbed by a distance x. Perturbed by a distance x means it is disturbed by a very small distance, and this is much less than the radius. So at that particular position, force on the charge particle will be q into E, and as it minus, so it will be minus sign. Force vector, if I write in terms of vector, so it will be minus of, in the question it is given minus capital Q, I have taken a small q. It's a representative thing, doesn't make any difference. So minus q, I write k into, I am taking this charge to be let us say q1, total charge of the ring, kq1 into x by r square plus x square whole to the power 3 by 2 I cap. So you can see that when the charge particle is displaced in that direction, force is acting towards the mean position. So that force will act as a restoring force. Now if I imply this approximation here into the equation, so let us check how much it is coming. So F vector is equal to minus k into q into q1 into x by, now you check, r square plus x square to the power 3 by 2 can be approximated as r cube, as x is much less than r. So if I substitute the result here, it becomes r cube into I cap. So you can clearly see that F is proportional to minus x. So if proportional to minus x means what kind of motion is that? We all know it is nothing but simple harmonic motion. So the charge particle in this particular situation will start executing SHM, and for that purpose we can also write minus of m omega square x I cap, and from there we can calculate the angular frequency of oscillation also. If I am not wrong, this omega value will come to be root under of, how much it is coming, kq q1 by I think this result is coming to be m into r cube. Yeah, that's what this is coming. Fine. So I think this is clear to all of you. Quite an easy case, not difficult. Fine, let's move on. Now this is interesting case. It's a good question, standard question although. So there is a ring for which this quadrant and this quadrant is only charged. All right. This is having positive charge, the third quadrant, and the fourth one is having the negative charge. And there is an electric field which is switched on along x-axis, and they are saying that when the field is switched on, the ring starts rolling without sliding. So the moment we see rolling without sliding, we used to get tension by thinking, yaar, it is going to be pure rolling again. But it's not difficult. If we stick to the concept, it will be very easy. So let us see how will we proceed. So what we'll do initially, I will take that, let us assume at an angle theta, a very small strip we are taking. This is angle d theta, and here we have charge dq, which is nothing but plus lambda r d theta. And similarly, exactly in the similar fashion, I will take, this is theta, this is also theta, this is d theta, so here also minus lambda r d theta. So if I only think about these two elements, you see that electric field is on the rightward direction. So if the electric field is on the rightward direction, then these two elemental charges will feel forces. So let us say that these are the two direction in which they will feel forces. This will feel force in that direction. I can write plus dq into E naught, and this will feel force leftward, which is equal to minus dq into E naught. So now you see that these two forces are basically two anti-parallel forces of equal magnitude, so they will generate a rotational tendency in that direction. So because of the torque, it will have a tendency of rotation in the clockwise direction. So just listen to me very carefully. I am just unfurling the chain of events step by step. So if it is getting a rotational sense of rotation in the clockwise direction, so this point of contact will have a velocity due to rotation in that direction. So the slipping tendency of this point of contact will be leftward. So in pure rolling, the point of contact should not slide. So for that purpose, if it has not to slide, for that purpose, it must have the friction acting onto it in the forward direction. So that is also another very important concept for here. So I think this concept is clear. Again, I will repeat for once that here you can see that the two elements that we have taken, plus dq and minus dq, since the electric field is on the rightward direction, plus dq will feeling force in this direction, minus dq is feeling force in the leftward direction, because of which it is having a clockwise rotational tendency, and because of this clockwise rotational tendency, the point of contact will have a movement tendency that is in the leftward direction. So now, as we know, in pure rolling there should not be any sliding. So since there should not be any sliding, so that means the sliding has to be stopped, so the friction must act in the forward direction, right? So now slowly and steadily we will write the equation of force, then we'll write the equation of torque. First, let us write the equation for torque. D tau is equal to what? Simply df into r. All right, fine. So here two forces are giving torque in the same direction, so I have to multiply a 2 factor over here. All right, so 2 df into r. So what is this r? This r is basically this one. Yeah, this is r. So if I take this radius as capital R, then this distance, this is coming to be r sine theta. It's a simple trigo, I think, not of much headache. This is coming to be r sine theta. So I'll straight away write df. This is the electrostatic force, so I have to be careful with this. I will write capital F only. Yeah, so df into 2r sine theta. All right, yeah, df is equal to what? Df is equal to simply dq into E naught, that into 2r sine theta. Okay, dq we can write lambda r d theta, that into E naught into 2r sine theta. So d tau is equal to 2 lambda r square E naught sine theta d theta. Okay, so this is d tau. If I integrate this factor, so tau will be equal to 2 lambda r square E naught integration of sine theta d theta, and this limit will be, if you check this variation, it is there only in this quadrant. No, we are thinking about this quadrant. So when this radius vector is along this x-axis, theta is 0. When it is along the y-axis, theta equal to pi by 2. So my integration limit will be from 0 to pi by 2. All right. So the limit is from 0 to pi by 2. So by integrating that, I am leaving the calculation for you. You will get the value of tau. Now once you are getting the value of tau, if you go back to the diagram once again, or for your convenience, I will take this diagram as a fresh. So this was the ring, and because of the electrostatic force, it was having a rotational tendency in the clockwise direction. But as we have seen, friction is acting in the forward direction, so it will try to produce a rotational tendency in opposite direction, right? So if I have to write the net torque equation for this, I will write, when I am writing torque equation for the system, I will write torque due to electrostatic force, that we have already calculated, minus torque due to friction about the center we are measuring. So this is simply capital R. So F into capital R, that is equal to I into alpha. So torque due to electrostatic force minus F into R. I for the ring, it is simply mr square into alpha is A by R. So I will get tau electrostatic minus F into R is equal to MA by R. If I am not wrong, no, MR into A. Okay, so this is getting MR into A. Fine. Right. So the next thing is that we have to write force equation. So now I will write force equation for the system. Now that is very delicate. When I'm going to write force equation for the system, you see the electrostatic forces were cancelling each other, है ना? Plus dq into E naught minus dq into E naught. So net force is 0 for this element, and if we sum all the elements, it will be 0. So there is only one force is acting, which is effectively forcing the center of mass of the system to move, is this friction. So I will write simply friction is equal to mass of the system into acceleration. So I will call this as equation number 1, this is equation number 2, and this is equation number 3. So if I substitute this equation number 3 into 2, we will get it from here. Tau electrostatic minus of F means MAR, that is equal to MAR. So tau electrostatic, if I bring this on this side, so this becomes 2 MAR. Then finally, if you substitute this result into equation number 1, then finally I will write from 1 2 lambda r square into E naught integration of 0 to pi by 2 sine theta d theta, that is equal to 2 MA into R. So I hope this entire case is clear to all of you. So whatever they want us to calculate in the question that will be given in the exam, we can calculate, provided by the fact that our concept is very strong here, right? I hope this is clear to all of you. There is no ambiguity. If there is anything which is pinching you, then just pause the screen, go through the entire calculation, do 1 or 2 times on your own, and things will fall in queue. Let us move on to the next one. It is an easy case. So there it is given, there is an electric field ai cap plus bj cap Newton per Coulomb. So immediately I will take the component of this field. If this is the electric field, then this is the x component, ex, which is equal to capital A, and this is ey, which is equal to capital B. So I will just check how many forces that can act on this Q. As per that, we will go for the final step. So here in this direction, you will have the force of Q into Ex, that is equal to Q into capital A. Downward direction, you will have the force due to weight, that is mg. In the upward direction, it will have a force Q into E of y. E of y is B, so that is Q into B, and this is the direction in which tension is acting. So these are the forces acting on it. So one by one I can write ki if the system is on equilibrium, then we can write that summation of fx is equal to 0 and summation of fy is also equal to 0. So final we can get the component of t also. If we get the component of t, then this is theta, means this will become theta, so this will become t sine theta, and in the upward direction we will get t cos theta. So from summation of fx equal to 0 equation, we are getting upward force is t cos theta plus qb, which is balancing the net downward force, that is equal to mg. So that is a resolution we are getting from summation of fy equal to 0. I'm sorry, this we are getting from summation of fy equal to 0. So what about summation of fx equal to 0? From there, this is the leftward force and these are the rightward force. So from summation of fx equal to 0, we can write t sine theta is equal to q into a. So if I just modify this equation a little, t cos theta is coming to be mg minus q into b, and t sine theta is qa. Dividing them, tan theta will result in qa divided by mg minus qb. All right, fine. Let's move on. So then there is another case for which I have just punched electrostatics with little bit of rotation, because from now onwards my target will be whatever the cases I will discuss, I will incorporate the things, or I will incorporate the concept from class 11th, so that simultaneously we can have revision for those topics also. So here in this case, as you can see, there is an uniform rod of mass m and length l hinged at this bottommost point. At the topmost point, there is a charge q, mass m, which is fixed to this particular point, and an electrostatic field is switched on in the rightward direction, that is of 3 mg by 2q. Now they are asking find angular acceleration of the rod when it is horizontal. So before the rod is becoming horizontal, I just want to check the cases at an angle theta with the horizontal, with the vertical. Suppose this is the initial position, and I'm assuming that the rod is reaching a position like, let me do it like here, let us say. All right, fine. So now I'm assuming that this is the angle theta. So when the rod is here, how many forces are acting in this direction? One force is acting, that is equal to q into e. So if I substitute the value, so q into 3 mg by 2q, it becomes 3 mg by 2. This is the horizontal force. Is there any other force? Yes. In the vertical direction, here one force is acting, that is mg. From the middle also one force is acting, that is also equal to mg. So they are the forces which will produce torque, right? Now if we check the direction of all the torques created due to these three forces, they are all in same direction. the direction is same, it is not changing actually, right? That is inward direction. All the torque is into the page, and I can calculate the torque. So tau net, we will calculate, say this force into perpendicular distance. I'm calculating about this point of hinge, right? So this is the point of hinge, and I'm calculating this distance. So you try to understand, if this is theta, this is also theta, then this distance up to this much is L by 2, because the weight of the rod will act through the center of mass. So if it is L by 2, then this perpendicular distance will become L by 2 sine theta. For this one, it is simple. This perpendicular distance will become L sine theta, and for this horizontal force, I have to take this as the perpendicular distance. If it is theta, this is also theta, so this will become L cos theta. So net torque will become force. First I am taking this force into perpendicular distances L by 2 into sine theta, plus then I am taking this force mg into perpendicular distances L sine theta, plus I am taking this force, that is 3 mg by 2 into L cos theta. That should be equal to I of the system into alpha. Now the entire moment of inertia of the system will be calculated about this point P. There is a hinging point, so I about point P. Now there is a chance of mistake that out of hurry you will just simply write Ip is equal to ml square by 3, but there is another particle attached to the top. So when I'm going to calculate the moment of inertia of the system, so I of the system about point P, I better write I of the rod about point P plus I of the charge ball about point P. So it should become rod about one end is 1/3 of ml square plus point particle at a distance of L, it is ml square, so it will become 4 by 3 ml square. So I can go back to the torque equation. I will write mg into L by 2 sine theta plus mg into L sine theta plus 3 mg by 2 into L cos theta is equal to 4 by 3 ml square into alpha. Now simple point is, when the rod is horizontal, theta, this angle will become 90 degree. So if you just substitute the value of 90 degree, you will get the answer. I hope this is clear to all of you. Not much of an headache, right? Yeah. Then next, I have given a part to also calculate the hinge reactions acting at this instant. Instant means when the rod is horizontal. So this is a challenge for this week. That is, we have to calculate hinge reactions when the rod is horizontal. Now I am adding two more challenges with this. One challenge is that when the rod is horizontal, now what if the hinge is removed? Then what will be the motion of the rod? That you have to figure out in presence of electric field, without the presence of electric field, right? So you have to find out the motion of the rod when the hinge is removed, the moment rod becomes horizontal, in presence of the electric field, and if the electric field doesn't stay, right? I hope all of you have thoroughly enjoyed. It's a small session, quick session. I hope it comes handy. We are coming very shortly with some of the unique questions regarding electric field, or never seen before questions, which will be extremely important for JEE Advanced and Foundation Level for Olympiad very shortly. Thank you. Thanks all of you. If you do like, please share, and your cooperation is highly needed. Thank you.